Bismillahirrahmanirrahim. Today we are going to solve Cambridge IGCSE Physics Paper 4 Theory Extended, and the subject code is 0625 and the variant is 42 for the session of May June 2024, and we have 1 hour 15 minutes for this paper, and this paper is carrying 80 marks, and the important information is we have to use the value of g, that is equal to 9.8 meter per second square. So we will start our question paper from question number 1. Question number 1 is that a load is suspended from a thread. The vertical force on the thread is due to the load is 0.75 Newton. Calculate the mass of the load. So this one is very easy. We know the formula for W is equal to mg, and m is equal to W by g. We had the value of W and we also have the value of G. So M is equal to W, W is 0.75 divided by G, that is equal to 9.8, and we get the answer that is equal to 0.077 kg. Remember, you need to write unit as well to get complete 2 marks. Okay, figure 1.b part is figure 1.1 shows the load suspended from the thread. Thread is load. A wire is attached to the load at the point X and pulled horizontally to the right. It means that it is pulled horizontally. In this direction it is pulled. Okay, the tension in the horizontal wire is 1.2 Newton. By drawing a scale diagram or by calculation, so it's our choice, whichever method we're gonna choose, we can choose. Determine the magnitude of the resultant force at X due to the load and due to the tension in the wire, and the direction of the resultant relative to the vertical direction. So this is an easy question. First we will draw a simple diagram. I will choose calculation method. It would be like that: 0.75 Newton, that is this thread way, and we know that this is 1.2 Newton. Both these values are given in the question. You can see from 0.75 thread and 1.2 Newton of the wire. Now join these value. We need to find this. By applying Pythagoras theorem we can find this, and we also need to find this theta value. So I'm going to use the formula for Pythagoras theorem, that is equal to c square is equal to a square plus b square, and the value of a is 0.75 square and the value of b is 1.2 square. You can calculate this value taking the square root of this and this. Your final answer would be equal to 1.42 Newton. So it would be equal to 1.42 Newton. So this is the magnitude. Now we need to find the direction. We know that tangent theta has a formula of perpendicular over base. So this is perpendicular or base, or you can say opposite over adjacent, and the perpendicular here is 1.2 and 0.75. Taking the inverse of this, theta is equal to tangent inverse 1.2 over 0.75, you get the value that is equal to 58 degree. So this is our final answer, calculating magnitude as well the direction, 1.42 Newton and 58 degree. Okay, moving to a C part. C part is that forces may produce changes in the size of the shape of the object. State 2 other changes that forces may change. Force can change the velocity, or you can write speed. It can also change the direction, and it can also change the acceleration as well. So you can write only 2 points from the points that I have already mentioned. So that was a simple question. Moving to question number 2. Define acceleration. We know that acceleration is the rate of change of velocity, or you can write Change in velocity per unit time is known as acceleration. Moving to its part B, our train has a total mass of 5,20,000 kg. The train accelerates at 1.1 meter per second square. Calculate the time taken for the train to increase its speed from 15 meter per second to 28 meter per second. So we have the formula here is A is equal to V minus U divided by T, and we have the formula for the acceleration, that is 1.1, and its velocity change is 28 minus 15, and we need to calculate the change in time, that is equal to T, and you can easily calculate T is equal to 28 minus 15, that would be 13 over 1.1. You get the answer, that is equal to 11.83 second, or you can round off to 12 seconds. Next part, calculate the force required to produce an acceleration of for 1.1 meter per second. So we know that formula for the force is F is equal to ma, and mass is equal to 5,20,000 given in the first part, and acceleration is equal, we just use in above formula, that was equal to 1.5. After multiplying it, we get the answer, that is equal to 572,000. So answer is 572,000 Newton. Again, you have to write unit as well to get complete marks. Moving to its third part, the train uses electric motor. Explain why the force on the train due to the motor is greater than the value calculated in 2. Obviously, calculations carrying the theoretical values, and theoretical value are the ideal value in which we don't have to waste our energies into like air resistance or any opposing force. And in real world, we cannot ignore the air resistance. That's why in real scenario the values come less compared to the theoretical value. So we're gonna write in our answer, in reality the train has to overcome additional forces like air resistance and friction forces. That's why in calculation it has a greater value, but in reality the value is smaller. So moving to question number 3. Question number 3 is that a student drops a heavy ball from the vertical height of 1.8 meter above the ground. So this was the answer for the previous. Okay, a student drops a heavy ball from a vertical height of 1.8 meter above the ground. The ball then falls to the ground. It does not bounce after hitting the ground. Describe the transfer of energy of the balls between stores when the ball begins to fall when it reaches the ground. Okay, when ball, let's say ball was at this height and you dropped it. At this point, it has the maximum potential energy because its height is maximum. Slowly, its height, when it started to fall, its height decreases and the potential energy start to decrease, and it would increase its kinetic energy because law of conservation of momentum, total energy of the system remains constant. So when it strikes the ground, at ground level the energy changes to thermal energy. So we're going to write our answer like that. Before the ball begins to fall, potential energy is at height, so maximum. When the ball falls, the potential energy changes to kinetic energy. When the ball hits the ground, the energy is transferred to thermal energy. So this is we're gonna write. Calculate the maximum speed the ball, ignore air resistance, show your working. So we know that the formula for the potential energy and kinetic energy we're gonna apply over here. Potential energy has a formula that is equal to mgh, and kinetic energy has a formula 1/2 mv square. So we're gonna cancel m with m. Now we need to calculate the maximum speed. Formula for the maximum speed would be v square is equal to 2gh, or you can say v is equal to under root 2gh. Value of 9.8 g, value of g, and the height is 1.8. The height was given in the first part over here. So by calculating this value we get the answer, that is equal to 5.9 meter per second. You also need to mention the unit as well to score complete 3 marks. So this was a simple calculation question, question number 3. Moving to question number 4. State 2 ways that evaporation differs from the boiling. This question is examiner's favorite. It has asked it multiple times. Evaporation occurs only at the surface, but boiling occurs throughout the liquid. So you can write that evaporation occurs at any temperature below boiling point, but boiling occurs only at the fixed point or at the boiling point. Okay. Moving to B part, figure 4.1 shows part of a container used to store mixture of a liquid and gaseous oxygen, steel walls of the container and the vacuum. The temperature of the liquid oxygen is minus 60 degrees Celsius. Determine the temperature of the liquid in oxygen in Kelvin. So this is the question where you need to convert a degree Celsius into Kelvin. You can easily convert by adding 273 in your degree Celsius, and degree Celsius was minus 160. When you add 273 in it, you get the answer that is equal to 113 Kelvin. So our answer in the Kelvin is 113 Kelvin. Moving to is second part. The container is made of a steel. Okay. The container is made of a steel and there is a vacuum between the inner and the outer wall. The outer wall of the container is at room temperature. State 2 method of thermal energy transfer that a vacuum prevents. Conduction and convection, because both these methods require the medium. Without medium, conduction and convection cannot happen. That doesn't require the medium is the radiance. So we write the two methods that are conduction and convection that doesn't require any medium, that does require medium to transfer. So in vacuum, these type of method can be used to prevent it from flow of heat. Moving to its C part, describe in terms of particle how a gas exert a pressure on the walls of its containers. We know that pressure in anything is due to when the particles vibrate, and due to their vibration they collide with each other and also collide with the walls of the container in which the gas is present, and this is called the pressure of the gas. So we can write that particles will collide with the inner wall of the container, exerting force on the inner wall. Pressure is exerted due to the first force per unit area. So this is how we define the pressure in the gases. Moving to question number 5. Question number 5 is that figure 5.1 shows a ray of yellow incident on the glass prism ABC. Explain. First part is saying that explain. Okay, you cannot see the first part. Now you can see explain why the ray does not change the direction at which it enters, because it is entering at 90 degrees, so it doesn't change. So we can write that the ray of light strikes at 90 degrees. Now the B part, the critical angle is 42 degree. Calculate the relative index of the glass. Show your working. We know the formula for the refractive index is that n is equal to 1 over sine C, n is equal to 1 over sine 42. That is equal to 1 over sine 42 would be equal to 1.5, and over refractive index for this would be 1.5. Moving to its C part. Before C part, there is also a second part. On figure 5.1, continue the path of the light through the prism and after it leaves the prism. So we need to draw the ray diagram for it. So it would be like that. First you have to measure the first you have to draw the normal. You can draw the normal like that. This is 90 degree, and drawing the normal would be like that. Now you need to measure the angle that is between this line and the normal line. As from the figure you can see that this angle value is is over here, that must be equal to, okay, now you can see clearly, this must be equal to 58 almost. So we can write that this would be 58, and our angle of critical angle was 42 degree. It means that we have a situation over here where our critical angle is exceeding where our incident angle is exceeding the critical angle. So it is the situation of total internal reflection. Now you have to draw the reflected angle also over here by making a 58 degree. Over here it would be like that. Hopefully you can clearly see it. Now you need to draw this line, because law of reflection say that angle of incident and angle of reflection should be equal. So this is 58 degree. Moving to a C part, that internet data can be transferred using infrared waves in optical fiber. State two advantages of using optical fiber to transmit data. They are more accurate, they are more efficient, it can carry a high rates of data, and you can write glass is transparent to visible light. That's why we use that. Moving to question number 6. Question number 6 is that a sound wave travels through air. Figure 6.1 shows a pressure time graph for the, this is very important, the figure is showing pressure time graph at one place. On figure 6.1, label 1 point C to indicate as compression and 1 point R to indicate a reflection. So this is compression, this is reflection. How I reach it? At compression we know that particles are closer, so pressure is much higher. So in this point it's showing the highest pressure. At rarefaction the particles are far apart from each other, so that's why they would have a minimum pressure. So we draw show the refraction R over here at the lowest point in the graph. Moving to second part, explain why this graph cannot be used to find the wavelength. Because there is no displacement given. Without displacement we cannot find the wavelength. This is not distance, this is time. Otherwise we can say we can measure between this distance, but this is over here is time. Moving to third part, the sound becomes louder and the lower pitch. State what happens to the amplitude of, yes, when the sound becomes louder, amplitude of the sound increases, and at the lower pitch the frequency of the sound decreases. So this is we're gonna write, this is a fact. Moving to B part, B part is that a speed of sound, a sound of frequency is 13 kilohertz that is transmitted through water. The speed of the sound in the water is 1500 meter per second. Calculate the wavelength of this sound. We know the formula is V is equal to F lambda, and for the lambda the formula would be V over F. So we have been given with the velocity that is equal to 1500. We have also been given 13 kilohertz, and we're gonna change into simple hertz. That would be 13 into 10 to the power 3. So after calculating we get the value of wavelength that is equal to 0.12 meters. So we're gonna write our answer 0.12 meter. State the approximate speeds of the sound in the air. That is equal to 343. You can write 340, or you can write 350, or you can write 330 or 335. Any answer close to it would be considered correct as well. So you don't need to confuse about it if your friend has written something else, but difference should not be much more. Okay, moving to question number 7. Question number 7 is a very interesting question and very easy question from the topic of magnetism. Question number 7 says that figure 7.1 shows the 3 bars that is of steel A, B and C. A, B and C. A student is given the 3 pieces of the steel. 2 of the pieces are magnetized and 1 piece is unmagnetized. Describe and explain how the student determine which piece is unmagnetized using only the 3 pieces of steel. Okay, we have to decide from these 3 pieces that which material is magnetized and which material is non-magnetized, and 2 are magnetized and 1 is unmagnetized. For testing which material is unmagnetized, there is only one method, that is known the repulsion, because magnetic material also give attraction. So we're gonna test one by one. If this is magnetized material, let's say hypothetically, and this is too magnetized, we're gonna close to it. If not repel, it means that they both are magnetized, and if north south, if they are attracting, you have to try this bar into other bar. If they are still attracting, it means it is not a magnet. Or if this part is not attracting, you have to check this. If this part is repelling, it means that these are the magnet. So repulsion is the only test. So we're gonna write that bring the end of one piece of steel close to the end of another piece. See that if there is any repulsion, attraction and repeat between different ends. The piece that attracts and repel is magnetized. The piece that only attracts and does not repel is unmagnetized. So this last paragraph is very important for your understanding and answer. Figure 7 point shows a circuit diagram of a step down transformer. Why it is a step down transformer? Because you can see that primary coil has the more number of turns compared to secondary coil. Okay, the main voltage supplied to the transformer is 240 volt. The output power of the transformer is 45, and the transformer is 100% efficient. In real life this is not possible. Calculate the input current to the transformer. So power input should be equal to power output. So the formula for the power input would be VI, and for the output it would also be VI, but we have been given that output power is equal to 45 and V is given, that is 240, and we need to calculate the current. So I is equal to 45 over 240. So we get the value of current, that is equal to 0.19 ampere. Ampere is the unit of current. You must need to write the unit as well to score complete marks. I am emphasizing on it because examiner has a very clear instruction. Some student even they know the unit but they didn't write the unit because they don't attempt carefully enough. So this is not a place where you have to lose any marks like that. Draw a label diagram for the step down transformer. On the labels state a suitable material for each of the component. We have already been given the diagram, but we have to label it as well. So first you need to draw these boxes, and primary coil should have the greater number of turns compared to secondary coil because it is a step down transformer, and it should be made of copper coil and material that is should be used as soft iron core. So these things are enough to get the completely 3 marks. So this is a step down transformer diagram. Moving to question number 8. Question number 8 is that figure 8.1 shows a circuit. The circuit is designed to switch a night light when the surroundings are dark. So it is our power supply. This is LDR, this is LED, and this is fixed resistor. On figure 8.1, draw the circuit symbol for the voltmeter used to measure the potential difference across the light dependent resistance. This is the repeat question from the session of February of the 2023. So you have to write, you have to draw voltage parallel to the LDR, or you can draw here as well. So both these answers will be considered correct. Second part, state the effect, the surrounding changes from light to dark. State the effect of this change on the resistance of the LDR. So obviously the resistance will increase because at darkness LDR would have more resistance. State and explain the effect of the change on the potential difference across the light emitting diode LED. The potential difference across the LED increases because the resistance of parallel combination of LDR and LED also increases. So you can write this answer as well. The potential difference across the LED increases because the resistance of the parallel combination of LDR and LED increases. Part B. Figure 8.2 shows another circuit, lamp A and lamp B or identical filaments. The current supplied is 0.5 ampere. Calculate the resistance of the lamp A, and it means we have to calculate the resistance of this RA. And we know that the current over here is 0.5 ampere, and it should be distributed like that, 0.25, because these both A and B are equal, identical filament lengths. That's why 0.5 would be distributed into 0.25 ampere and 0.25 ampere. So voltage will remain same at point A and point B as well. So we're gonna use Ohm's law to calculate it. We know that formula for the Ohm's law is that V is equal to IR, and we need to calculate the resistance at A. It would be equal to R is equal to V by I, and the value of V is 240 and the value of I is 0.25. So after calculating this, we get the value that is equal to 960 ohm. So again you have to write the unit as well. So 960 ohm is our answer here. Again, simple question and simple applications of Ohm law is given in this question. Moving to question number 9. Radioactive isotopes that emits ionizing radiation are used in hospital. State and explain 2 safety precautions from radiation. This is the favorite question of examiner over the years. That what precaution should be used. Safety procedure 1 should be reduce the exposure time. Lower amount of radiation would be absorbed into the body if your exposure time is if you decrease your exposure time. Safety procedure 2 would be that use protection like lead shield. It would not allow to penetrate into our body. So these 2 points you can write with explanation. Second part is that give 2 reasons why alpha emitters are not used as a radioactive tracer inside the body. Because radiation cannot penetrate our body to be detected, because alpha particle has a much greater size there. They do have a greater tendency of ionization ability, but their penetration power is very less, so they will not penetrate in our body. Second answer will be high ionizing power inside the body. So these are the 2 reasons. We do not use alpha emitter as in radioactive inside the body. B part. Sodium 24 is an isotope of sodium that has a proton number of 11 and a nucleon number of 24. Sodium 24 decays by emission of beta particle. We know that beta particle is carrying 1 electron from magnesium, and we need to balance. Magnesium has mass number that is 24, so 24 plus 0 is 24, then 12 minus 1 should be equal to 11. So over here we would put 12. So this was question number 9. Moving to question number 10. Question number 10 is that the solar system includes the sun and planets. State 2 other types of natural objects that orbit the sun. First object that orbits the sun is asteroid and comets. So these are the answer you can write. B part. State the shape of the orbits of the planet. We know that the shape of the orbits that planet is elliptical. Moving to C part. C part says that figure 10.1 shows the orbit of an object around the sun at a point A. The object is closest to sun at point B. The object is furthest away from the sun. Okay, state and explain the energy transfer as the objects travel from point A to point B. Statement: potential energy increases from point A to point B and kinetic energy decreases. And the reason is the total energy of that system remains conserved. So loss in kinetic energy would gain in potential energy. Okay, moving to is D part. D part is that Jupiter is 7.8 into 10 to the power 11 meter from the sun. The speed of the light in the vacuum is 3 into 10 to the power 8 meter per second. Calculate the time taken for the light from the sun to reach Jupiter. We know that the formula for the speed is equal to distance over time, and formula for the time would be distance over speed, and distance is given in the question, that is 7.8 into 10 to the power 11. Speed is also given, that is 3 into 10 to the power 8 meter per second. After dividing this, you would get the answer in the time, that is equal to 2.6 into 10 to the power 3 second. So this was an easy question, a simple calculation like kinematics. Okay, moving to question number 11, last question of our paper, that is very short and simple question. Name the galaxy that contains the sun. And we live in this galaxy, that is Milky Way. Part B, light observed from the distant galaxy is redshifted. State the theory of the universe that the observation spot is theory we all know about it, Big Bang theory. Part C, cosmic microwave background radiation, CMBR. Cosmic microwave background radiation is observed at all points in the space. State when the radiation was produced. Shortly after the universe was produced, we believe that this radiation was exposed. Explain why this radiation is now in the microwave region and the electromagnetic spectrum. Universe is expanding day by day and cause the radiation to redshift. So this is our final answer of the final question. Hopefully you get the understanding of this paper. If you do have any queries related to this paper, you can ask in the comment section. I will reply as soon as possible, and do not forget to share with your friends. Also do like this video and do not forget to subscribe this channel. Thank you so much for watching this video. Allah Hafiz.